Hello and welcome everyone. This is the very first video for my video game design tutorial. Basically, it's not so much of it's not so much of a tutorial, but I kind of go into video games and I kind of tell you how the code and media, work together to actually create these things called video games. And I decided I would go into Minecraft first because it's very simple and it's a good beginner. Then after that, I'm going to try to do Half-Life 1 and then maybe Half-Life 2. Now, let me see. Okay. Is general Minecraft, and most likely if you're watching this, you know just about everything above vanilla Minecraft and you've at least played it once. So, when we how do you make these things work? You first of all think, well, okay, these are squares right here. And these squares had to be made based on OpenGL in this case because Minecraft is built in Java using the lightweight game Java language, I think it is. Yeah, I believe it is that. It is basically a import or a library that you can use in Java to make OpenGL, OpenCL, and OpenAL a lot easier to use. Of course, and pig is freaking loud. And of course, a lot of Slick, New Dawn is add-on to LWGJL, which is shorthand for the library. And it kind of adds a lot more simplicity, compared to just using the LWGJL. But anyways, what we do here when we create a block is we tell the OpenGL saying, okay, we are going to create each vertex of the object. And if you don't know what a vertex is, let me get the snow off here. You see that look at the very center of the screen where my cursor type thing is. You see the corner right there? That is a vertex. Now, if I move away of the block, you can see that the outline isn't there. So you basically have the corner right there, which is a vertex. And then you create another vertex, which might be at the bottom instead of the top. And all together, and let me count just to make sure, 1, 2, 3, 4, 5, 6, 7, 8, you'd have a total of 8 vertexes, or vertices, I meant, per square. And of course you have the snow, which is a slightly, it's a slightly smaller, or not as tall, block, so you would have the bottom vertex not as long as this one would be comparison to the top part. Now, if you were to actually do coding for this, you would basically say, okay, within X, Y, and Z, and you might reference this based on one vertex, you would move 10 up, 10 right, 10 down, and usually you would just do it from there, and then you would get a cube. Then you would say, okay, this is in a cold area based off of this method in Java, so we're going to add some snow to it. So therefore, you probably go into another method saying, okay, this is where the block is. We just move up 12, and then 10, then 2 down, and stuff like that, and that would create the snow. Now, if you don't know this concept at all, I would really, really prefer you to go into Java and do some basic tutorials. Try to get into the intermediate tutorials, and then try to get into OpenGL. If you understand, you don't really need to know the programming language so much. A little bit you do, but if you understand the concept of what OpenGL is and how graphics work with video games with this OpenGL, you're practically all set and understand what I'm saying. So what you would basically do with the textures is that you would assign each side of the texture a certain texture, but of course with the dirt, it's all the same on each side unless you have a function, or I'm sorry, a method saying, can you see sky? If it is, then most likely the top is grass. Of course, you can assign this in OpenGL. I'm not going to go into the very details of that, but I'm basically just saying just the idea of it. This is not totally programming orientated. This is more the idea of how some coding and methods and stuff like that interact with each other with the game. It's a little miscellaneous. But back to here, we kind of look at AI in many games, and Minecraft has really simple AI, but it's really, really hard to make AI in a continuously dynamic world. In this case, for example, Skyrim. Skyrim has extremely simple AI. You'd basically have seconds, minutes, hours, days, and then you have basically pre-programmed paths where the AI continuously travel on. And based on certain conditions that you've done, whether you've done a mission or you talk to someone, that person might change its way path. A way path in video games is, let's just say you're the programmer, and you say, okay, I want an object right here that would move this way, this way, this way, this way, this way, this way, and this way, and walk back. Now, this can be done in programming. Of course, in game engines, you can set it up and graphically see it. So you would basically say, okay, the person would be doing this, walking back and forth. Well, how do you do that in Minecraft? Well, here's the trick. You don't. You don't have pre-programmed areas, even though it is possible to have pre-programmed areas. But in this case, Minecraft is more of a, what would you say, more of a sandbox type of game. So you would have more randomness, more just do whatever you want type AI. And that's the hardest AI to accomplish, especially to get it sophisticated. Now, ever since the update 1.2.5, the AI has dramatically changed and became a lot better compared to original ones. For example, there is probably additional methods to the actual AI saying, okay, if there's more than one block of a drop here, do not walk over this. And by doing this, you would use something called raycasting. Raycasting, I'm not really for sure if Notch or Jeb use raycasting specifically, but they had to use something similar to it. Maybe sphere casting, even though sphere casting is not really the point. Raycasting is basically where you shoot a ray from an origin to an endpoint and you see if there's any objects that intercept that ray. If so, you can return the object number or whatever you have in your programming. Raycasting does not come with most lower level programming languages, but if you do stuff like app, GameKit, or Dark Basic, usually there is. So in Java, you have to kind of make your own unless there's a specific library. But even then, that's a little tricky because you might not have the right compatibility to that library. So you basically have like a raycast. A raycast goes through here and says, oh, you only have one block of air in the way, so the AI would drop down and just continue on with their path. So the way that, according to the programming in Minecraft, which of course I do a lot of modding, so I have the understanding of how AI works, there are a couple methods within Minecraft that I kind of realized that, for one thing, enemy mobs, they usually go around and they try to go to darker areas and do not go to lighter areas. And this is really good because, of course, when an enemy mob goes into the light, it kind of burns. Well, it doesn't kind of burn, it kills them on fire. Now, of course, not all mobs are like this. For example, the Enderman can be out in the light, but tends to, like, it senses the light and kind of goes away and tries to find somewhere dark, then they kind of just walk around. Of course, when it's raining, they continuously teleport because rain or water hurts them, which I think is kind of interesting, to be truthful. So we have this understanding of environment input to the AI and the actions done based on code. So the Endermen, when it's raining, they go away. When there's light out and there's mobs, then the mobs try to run to the darkest area. If not, they eventually die. And when it comes to animals, they randomly do stuff. They try to avoid big heights based on ray casting. And they also try to maybe mate a lot, and especially with animals, they might, like, I don't know if animals can really do it on their own. I know villagers can, but usually with animals, you would give them hay and stuff like that, and there would probably be a method saying, okay, hay is full, meaning that they just ate it, and when one is near each other, there is a method probably to say, okay, is there an entity within this area? And then they run to each other, and then boom, comes out a baby. Now, that would be another way of doing it. Now, the way you would actually detect which entity is what is usually done in my way, probably not Minecraft's way, but most likely my way would be sphere casting. And of course, sphere casting means you have a sphere, and that sphere kind of goes a little and then it goes out, and whatever is inside that sphere is detected and returns an ID number. Now, you might have like an array, which is basically a collection of data, an array of numbers that each spot within the array is the object number. Each object number spot either has a 0, a 1, a 2, or 3, or 4. A 0 might be a pig, a 1 might be a cow, a 3 might be a sheep, a 4 might be a wolf. Now, if you detect a certain mob, animal mob in this case, having the specific number, and chunks are not loading, that is equal to its own animal mob, basically meaning that if one animal mob finds another animal mob of the exact same type, and then they might go through another method saying that, oh, that one's full of hay too, let's mate and have a baby, and that's basically how that works. Now, programming wise, you might have to be a little creative about it. I just kind of give you the guidelines of how it works. Ooh, this is an interesting place. Huh. Okay, anyways, back to the subject. Now, another thing is, when it actually comes to night and day, it's a really simple system. All you really have to do is you have to have a timing system, seconds, minutes, hours, whatever. You can have those seconds, minutes, or hours do whatever you want, and well, whatever type of equivalence to real time. And from there, you can actually change the, I don't know, darken the ambient light, which is the overall light in the environment, a little bit lower, not too low. In this case, it's a little bit darker, but not too dark. And you can also probably make it so that the sky changes, of course, like you can see the stars, where the other time you just see a blue sky, which is usually a texture change. And you can also have, like, for example, the moon, maybe as a individual entity that continuously faces you, which is like a plane or a sprite. But that tends to be a little hard to do when it comes to OpenGL. Okay, so we kind of went over how the general graphics work. We figured out how textures kind of work. We kind of figured out how the artificial intelligence work, and a little bit on the environment of the game and how it works. Now, I am kind of rushing through this because I kind of want to get into Half-Life a lot, because Half-Life's really interesting. Especially Skyrim. Skyrim has a boatload of stuff to talk about, and Minecraft tends to be very simple. If you're a game developer, you kind of understand how this works. But I'm just kind of go over the basics of it. Like, for example, like how the leaves actually disappear when the wood is gone. You would have a method saying, okay, is there? It's gonna do might do an individual sphere cast where it's saying, okay, so is there an object around me other than air? And I'll say yes. And then they'll have another method maybe saying, okay, what is the individual objects near me that are wood of this type, or this type, but not leaves or anything else? And then it'll say, here is some, here is there, and based on the distance, X, Y, and Z from there, it will determine whether the leaves die or not. Like if I got some leaves, for example, and just for, let me do this. Whoops. Now if I just, whoops. Why is this doing this? Oh. Okay, sorry. Wrong mouse. Sorry about that. But anyways, if I did this, eventually, over time, the leaves would disappear because there's not enough wood near it, or at least it shouldn't. Let's just double check. So we're going to leave this here, and most likely these leaves would disappear because of the lack of wood around it. And these leaves around here survive because there's wood around it. And of course we all know this because we played Minecraft before, but based on the programming side, it shows that it'll like detect within a sphere distance or whatever. What? Oh yeah, I forgot. They actually have armor now. Man, I've never seen a golden one before. Okay, so this kind of concludes the first video. The second video I would probably go over a little bit more about how Minecraft works with the coding and all that. I'm gonna wait for this to actually disappear. I don't know if it will or not for some reason. I know these are disappearing, which kind of proves my point. But anyways, I know this one's like a little obvious, but anyways, thank you for watching. Make sure to leave a like so more people can watch, and also subscribe to help me out and everything. And also, if you could share this video, it would be absolutely fantastic. This is MrSovr, and thank you for watching.